All right, folks, Friday was our first day of talking about composition of functions. And what we're going to do is continue on with that today. So we have been working with equations as functions, and we have seen that f of x is the same thing as y. So just a quick review here of function notation. Remember that this says a function of an input x is equal to an output, which is y. So we have talked about all of the different parts of this notation. The f, remember, is the name of the function. The x is the input for the function. And then finally, this y that we see over here is the output of our function. And remember that this all goes along with the reason that functions exist. A function's job is to take an input x and connect it to an output, which is y. And we also know that a function makes that connection by using a rule. So let's make this a little more specific. Let's have f of x is equal to 2x plus 1. So now, again here, that f is the name of the function, that x is the input, but now what we see over here is actually the function's rule. And that function rule tells us how x and y will get connected. So this tells us that in this particular function, you'll do 2 times the input, which is x, and add 1, and that's how that y value will be produced. So we have seen that if we need to do something like f of a negative 3, that means to take the function whose name is f and input negative 3 as the x. So to take the function whose name is f and input negative 3 as the x. Well, here is the rule for that function whose name is f. So I'm going to input negative 3 for that x and do 2 times negative 3 plus 1. And then we'll work that out. So first we would do 2 times negative 3, which is negative 6. And then the negative 6 plus the negative 1 would be negative 5. So notice when the input x is negative 3, the output y would be a negative 5. So at this point, we should be aware and comfortable with how all of that works. Now, on Friday, here's what we did. They could give you a function like f of x equals x squared minus 2. And then another function, g of x, is equal to 5x plus 1. And then they could say to you something like find f of g of negative 3. So this is a composition of functions. It's a problem where we are going to be combining 2 functions. Now I want to remind you how this goes. When we're doing a composition of function problem, we always start with that innermost function. So on this problem, the first thing that I will calculate is g of negative 3. Now remember what that means. That means to take the function named g, which is this function. So I'm going to be using this rule, 5x plus 1, and what I want to do is input negative 3 for the x. So instead of 5 times x plus 1, I want to do 5 times negative 3 plus 1. So we take the function named g, 5x plus 1, and input negative 3 for its x. So to work this out, first we would multiply 5 times negative 3, which is negative 15. And then we would do negative 15 plus 1, which is a negative 14. Now remember, at that point we aren't finished, because all we have figured out is just what g of negative 3 is. So in this problem where we see g of negative 3, we can now replace that with what we know it's equal to, which is negative 14. So now our problem becomes f of negative 14. Which means we're going to take the function named f and input negative 14 for its x. So the function named f is x squared minus 2, and when I input negative 14 for the x, it's going to be a negative 14 squared minus 2. Now, when you do negative 14 squared, you're going to get a positive 196, and then 196 minus 2 is 194. So the final answer on this problem would be 194. So we did g of negative 3, found out that was negative 14, so this becomes f of negative 14, and then when we work that out, we get 194. So that's what you did on Friday. We're going to continue to work with these composition problems today, but the thing that will be different for us is that we won't be seeing a specific input any longer. So let me show you what I'm talking about there. Problems today are going to look like this. Let's say we have f of x is equal to 3x plus 2 and g of x is equal to 4x plus 5. So f of x is equal to 3x plus 2 and g of x is equal to 4x plus 5. What we are going to find is f of g of x. Now you'll notice that for the most part this looks the same as what you did on Friday. But you should notice that we don't have a specific number here that we're going to use as our input. So what that means is when you work out this problem, you are not going to get just a number for your answer any longer. You're not going to get a specific output because you don't have a specific input. Instead, what's going to happen is you are going to find the rule for f of g of x. So your answer should look like a function rule. Now, the good news is that the way we work with this is going to remain the same. So we would still begin the process with the innermost function. So the first thing I need to know is what g of x is equal to. So I'm still going to start with the innermost function. I need to know what g of x is equal to. Now the good news is I'm not going to have to do a lot of work to find that out because they told me g of x is equal to 4x plus 5. So g of x is 4x plus 5. I can't work that out. I don't know what x is, so I can't do 4 times x and then add 5. So what that means is this is just done. That's as much as I can do with it. I know that g of x is 4x plus 5. So right here what I've highlighted, this g of x, can be replaced with what it's equal to, which is 4x plus 5. So that makes this problem f of 4x plus 5. So to get to here, let me make sure I'm clear on this. I am replacing what I have highlighted here, g of x, with what it's equal to. It is equal to 4x plus 5. So the problem becomes f of 4x plus 5. Now, I find that this can be a little confusing for folks. But I don't want it to be for you. I want you to keep in mind when it says to find f of something, what that means. Okay? If I were to say to you, let me just come up here and do this. If I were to say to you, I wanted you to find f of 2, you know what that means. You know that means to take the function named f and input a 2 for the x. So if I take this function named f and I input a 2 where that x is, that would make this 3 times 2 plus 2. And you would work that out. If I said to you, I want you to find f of a negative 1. Again, you know what that means. You're going to take the function named f and input negative 1 where you see x. So you're going to take this function and input negative 1 where you see x. So that would be 3 times negative 1 plus 2. And you would work that out. If I said to you, I want you to find f of question mark Okay, that means take the function named f and input a question mark where you see the x. So where you see this x, you're going to put a question mark. So this would be 3 times question mark plus 2. Now my point with that last example is that it doesn't matter what they have inside the parentheses. When I see f of whatever that might be, I take that something that's in the parentheses and I input it for the x. So we're going to do no different here. When it says to find f of 4x plus 5, we're going to take the function named f, which is 3x plus 2, and we're going to input 4x plus 5 for the x in that problem. So this 4x plus 5 that you see right here is going to replace this x in that function. So instead of 3 times x, you're going to do 3 times 4x plus 5. And then you've got your plus 2. So no different. This right here is your input. So go to the function named f, and where you see the variable x, input 4x plus 5. So again, instead of 3x, I have 3 times 4x plus 5. I have input the 4x plus 5 where that x was in that function. Hopefully that made sense. Now, here's what you're going to do with this. You are going to simplify this as much as you can, but you're going to keep in mind that there is no way to completely work this out because you don't know what x is. So to simplify this, the first thing I see I could do is I could distribute and make these parentheses go away. So if I do 3 times 4x, I would get 12x. If I do 3 times positive 5, I would get positive 15. And then I have my plus 12. Looking at 12x plus 15 plus 12, I know I can add the 15 and the 12 together, combine those like terms. So this would be 12x plus 27. But notice when I reach that point, that's as far as I can go. There's nothing more I can do. I can't work this out because I can't do 12 times x when I don't know what x is. So the final answer on this problem would be 12x plus 27. So f of g of x for this pair of functions would be 12x plus 27. So you're finding a rule instead of a specific answer. Is what you're doing. All right, so let's try another one. This time around, let's do f of x is equal to 2x minus 1. And g of x is equal to 3x plus 5. Let's find g of f of x. So again here, notice no specific input for x. No specific input. So we're going to be finding a rule here. So we would start with our innermost function. So the very first thing I need to figure out for this problem is what is f of x equal to? Now again here, I'm not going to have to work for that. I'm not going to have to work to try to figure that out. They told me f of x is equal to 2x minus 1. So I can write here f of x is equal to 2x minus 1. I can't simplify that. I can't work that out. So that's just done. That's just finished. So now I can replace what I have highlighted here, f of x, with what I know it is equal to. And it is equal to 2x minus 1. So this is going to become g of 2x minus 1. So that's next up for me. That's what I need to do now. Now again, don't let that confuse you. This is telling you you're going to take the function named g, which is 3 times x plus 5, and you are going to input 2x minus 1 for x. So we're going to input 2x minus 1 for the x in that function. So instead of 3 times x, you're going to have 3 times 2x minus 1. See, I am removing x from the problem and putting 2x minus 1 in its place. And then my plus 5. So whatever you happen to see here in the parentheses is your input. It replaces the x in this function. All right, so now let's do a little simplifying. 3 times 2x would be 6x. 3 times negative 1 would be negative 3. So we end up with 6x minus 3 plus 5, and then we can combine the negative 3 plus 5. Negative 3 plus 5 is a positive 2, so that's going to be 6x plus 2. Now, that's as far as I can go. I can't work that out any more than it already is, so the final answer for this composition of functions would be 6x plus 2. That would be its rule. Now, I want to show you one last thing with this. One last thing with this, and what it is just a different way of writing the problem. It's not actually anything new. So let's say we have f of x is equal to 2 plus 8x. And that we have g of x equal to 3x minus 4. So these are my two functions, 2 plus 8x for f of x and 3x minus 4 for g of x. Now, this time I'm going to change the way I write the composition. I'm going to ask you to find g with a little circle and an f, and you'll notice that's in parentheses, of x. Now, what I want you to know and understand is that this circle that you see right here is the symbol for finding a composition. So when you see g circle f of x, that actually means g of f of x. And I want you to notice that it goes in order. So because g comes first over here, he will go first when you write this as a composition. Because f goes second in your problem over here. So that little O right there is actually like that of. G of f of x. So g of f of x is the way that would go. These are two different ways to say the same thing. All right, so we know what to do now. If we were going to try to find g of f of x, we would begin our work by figuring out what f of x is. So down here, f of x I know is equal to 2 plus 8x. Easy peasy there. We know exactly what that is. So now I can come over here and I can replace what I have highlighted with what I know it is. This is g of 2 plus 8x. f of x can be replaced with 2 plus 8x. Now again, don't let this bug you. Think about what it's saying. G of 2 plus 8x means to take the function named g, 3 times x minus 4, and input 2 plus 8x for the x in that function. So right here where I see the x in that function, I'm going to replace him with 2 plus 8x. So this is going to be 3 times 2 plus 8x minus 4. Whatever you see inside the parentheses on that function notation is what you input for your x. All right, time to simplify. 3 times 2 would be 6. 3 times a positive 8x would be a positive 24x. And then I've got a minus 4 in my function. I can do 6 minus 4, so I get 2 plus 24x. And then I look at that and I don't see anything else I can do. So that is my answer. So g of f of x is 2 plus 24x. Or you could put 24x plus 2 and that would be correct as well. So when you see it written this way using the little circle, it is still a composition problem and you can easily transfer it from this notation to this. All right, so as you're working on these today, if you have questions, please be sure and let me know. We can set up individual Zoom calls or whatever we need to do to handle those. We will be quizzing at the end of this week on everything that we have done up to this point with functions. So start thinking about that and preparing for that. And if there's anything that you need help with before Friday, be sure and make that known. Let me know.